Good morning. Let's continue with the cache memory mapping techniques. Today's session will discuss about two types of cache memory mappings, which include associative mapping and set associative mapping. In associative mapping, a block of main memory can map to any line of the cache that is freely available at that moment. So there is no restriction like in direct mapping. We can store in any location in the cache if it is free. This makes fully associative mapping more flexible than direct mapping. Here the physical address is divided into two sections. First section denotes the block number or tag and the block itself. So this is the way the physical address is divided in associative mapping. Example, here all the lines of cache are freely available. Thus any block of main memory can map to any line of the cache. If all the cache lines been occupied, then one of the existing blocks will be replaced. Let us see the advantage and the disadvantages of using associative mapping. It is very flexible method and it provides efficient space management in cache memory. Disadvantages include a replacement algorithm is required. It suggests the block to be replaced if all the cache lines are occupied. We can use algorithms like first come first serve, that is FCFS algorithm, or least recently used, that is LRU algorithm can be used for this. Cost of implementation and associative search time is higher in the case of associative mapping. Now we will discuss about the last method, that is set associative mapping. In this method, cache lines are grouped into sets where each set contains k number of lines. A particular block of main memory can map to only one particular set of the cache. However, within that set, the memory block can map any cache line that is freely available. The set of the cache to which a particular block of the main memory is mapped is based on equation cache set number equal to main memory block address modulo number of sets in cache. Let's see this with an example. Consider the following example of two-way set associative mapping. Here we are considering two lines into a set. That's why it is called as two-way set associative mapping. It can be any number. For a general, we can say k-way set associative mapping. Here k is equal to 2, suggests that each set contains two cache lines. Within that set, block J can map to any cache line that is freely available at that moment. If all the cache lines are occupied, then one of the existing blocks will have to be replaced. In set associative mapping, the physical address is divided into three sections, including tag, set number, block. So we will see the advantage and disadvantage of set associative mapping. Since this is a combination of direct and associative mapping, it overcomes the disadvantages of both, the contention problem of direct mapping and higher associative search time of associative mapping. But implementation is difficult and also costly since it uses fully associative mapping within each set, which requires a replacement algorithm. So we have discussed about various cache mapping techniques, and we already discussed about different types of memories which include registers, cache memory, then primary memory, and one more topic is there, that is about secondary memory. That you can write it as an assignment. I will give you instructions through Google Classroom.